What it is up? It is Friday, May 27th, 2022. Welcome to Shaft Algo Guy. Okay, see, so I said the name of this channel without vacillating. So I'm stuck with Shaft Algo Guy from now on. And yeah, so thanks for watching. In the spirit of it being Friday and Memorial Day weekend coming up, I'm going to do an easy Leetcode problem today. Yeah, because I don't want to stress too much. And this problem is off the blind 75 list, and if everybody who's familiar with Leetcode grinding knows, yeah, that's one of the best, most representative lists out there in order to pass the coding interviews and become good at algorithms and whatnot. So today I'm going to do an easy problem because I did try doing a harder blind 75 problem earlier today, and that was didn't work out. These are tough problems, and my goal is to master all these problems before a certain date, which I'm not going to talk about too much. But for now, yeah, I'm going to get into this problem, and yeah, thanks for watching. If you like my video, like, subscribe, and comment. Let me know how I'm doing. It helps the algorithm, and it helps my channel grow. Okay, so yeah, this problem today is again on the blind 75 list. It is a simple problem, but it is a famous problem because an engineer, I guess in 2015, named Max Howell, who worked on Homebrew, which is a system that helps install other packages. It's a package installer for Macs. I think it's probably for more than Macs, but I use it on Macs all the time. He got mad apparently, which it looks like, and this was almost 7 years ago now. He got mad because Google rejected him because he couldn't invert a binary tree. He put it on Twitter, and there was a bunch of fun that followed. So I think I remember a post from Gail Lockman McDowell from Cracking the Coding interview where she was kind of going back and forth and debating him about that. And I think he had recanted somewhat. I don't know where that post is. It's on Quora, I believe. But I'm not going to talk about that. I'm talking about interview problems. So here today, I'm going to talk about inverting this binary tree. And this problem is a pretty simple problem if you know your basic tree algorithms. Okay, so basically what is the question? And I liked it, and again, it's an easy problem, and it was number 226 on Leetcode. So if you have a tree that looks like this, 4, 2, 7, 1, 3, 6, 9, the tree is turned into 4, 7, 2, 9, 6, 3, 1. Okay, so basically you're literally switching the children of each of the children of the tree recursively throughout the entire tree. So 2 switches with 7, but remember 7's children are also 6 and 9, so they get carried over in that operation. So 9 switches with 6, and so on. Okay, so again, the simpler example is 2, 1, and 3, and then 2 switches its children to 3 and 1, and since 3 and 1 don't have children, they don't get carried over. Okay, so let's get to it. So first, the thing I want to do is I want to, since this is a standard tree problem, we're going to do a depth first search. Okay, and in this depth first search, we're going to first put our base case, which is if the root is null, return. And okay, so what I want to do now is I want to invert this tree. How can I go about doing that? Well, the first thing I can do, if you've ever written like a swap function, I can just simply write a swap function. It's not applied to an array in this case. It's applied to tree nodes, right? And root.left equals temp. Okay, so basically what I'm saying is storing temp, the right child, in a temp variable, and then I'm assigning the right child to the left child. Okay, and in the left child, since I already have the right child, the previous right child stored in a temp variable, that's what I'm going to reassign to the left child. So you can't obviously do this directly without this temp, because otherwise the right will get overwritten and you'll have 2 copies of the left, and you don't want that. Okay, and so is that it? No, we still have to do it for all the children. If we did this for only this, without doing it recursively, we'd only swap the topmost nodes of the tree, and everything else would remain the same. So, and let's see. So root dot left. So we're going to recursively go through all the children, right, and apply the same inversion process. And let's make sure in our helper method we call it in the main function. We run the problem. There you go, it's accepted. And there you go, it's accepted. And pretty good runtime. Okay, so yeah, that's it. Quick problem. I'm done for today. Thanks for watching. If you like my videos, tomorrow I'm going to do a more complex problem. I just wanted to get this out of the way for today, and I will talk to you later. And just one last note on the runtime. This is an O of n operation because every node is visited once. I just got to remember to put the runtimes there. Okay,